Okay, so here's our first factoring problem, which I will show you from start to finish, problem number 1. First thing we need to do is find out what we can extract from this problem. There will always be something in common in these factoring problems, and you'll notice that 12, 4, and 20 means we can extract a 4. They have a common x. They each have an x to the 4th minus 1, and that looks like it. Now I like to use brackets at this point. That just reminds me that everything in the bracket has a long way to go. A lot of tidying up inside there, and I don't like to leave brackets in my final answer, so that's just a reminder for myself. So what is left behind from this first thing? I see a 3 and an x, and the 2x minus 1. Then the only thing left in that middle section is the 2x squared minus 11. So I didn't need the parentheses there. That's okay. And close the bracket. So that concludes the extracting part of this problem, which we always need to do. Anytime we extract something, we need to see and check to see if it factors farther, which in this case, this x to the 4th minus 1 will factor farther, so we can't ignore that. So I'm going to factor that right now. And I'm going to start to tidy up inside the brackets here. Distribute, combine like terms, and the next step. Now, one thing that is tricky here, we did factor that part that we've extracted, and it's going to factor twice. This x squared minus 1 does factor farther. But the x squared plus 1 does not. So that concludes the outside of our brackets. Let's tidy up and combine like terms the inside of our brackets. Okay. Now inside the brackets we start the factoring process all over again, and you need to first see if you can extract anything out of those combined like terms. 8 and 23 and 36 have nothing in common, so we cannot extract anything out of them, which means we will attempt to factor this into binomials. Now the 8x squared can be a little challenging because we have two choices for our fronts. We can use an 8x and an x to get that 8x squared, or we can use 4x and 2x. So two choices means we have twice as much work. The last numbers have to multiply to be 36. I always like to write down the choices for that. So starting with 1 times 36, 2 and 18, etc. Okay, here is a time saver that I had mentioned in class. When we go to attempt this problem, one of these 5 combinations has to be at the end. If you think it's 4x and 2x, here is your time-saving hint. Every pair of these possible choices for the last number has at least one even number. And you cannot put an even number next to a 4 because you could extract a 2 from them. You cannot put an even number next to a 2. Obviously, you can extract a 2 from them. Which means you don't need to attempt 4x and 2x. It wouldn't be possible. Remember, if you can't extract any numbers from this line, then you can't extract them later. So 4x and 2x are not possible. So let's head to the 8x and the x. And similarly with the 4 and the 2, we cannot put an even number next to an 8. So when we go to attempt, we won't even start with the 6 and 6, both even numbers. If we move up to the next one, the 4 and the 9, I can't put a 4 here, which means I could put the 9 there. So some process of elimination, and now we are just kind of guessing, seeing if this thing works. If you were to do your FOIL technique, I see a 32x here, and I see a 9 right here, 32 and 9. The question you have to ask yourself is, can you make a negative 23 with those two numbers? The answer is yes, as long as the 32 was negative, which means the negatives here, positives here, and that concludes the factoring for that section. Bring what you've extracted earlier down. Don't leave that out. And box your final answer. Okay. So the next thing I'm going to do is put up problem number 2. And what I need you to do is press pause after I get it up here to give yourself a chance to work on it. And then hopefully if you press pause at the correct time, I will shortly after reveal the answer to see if you got it right. So here's problem number 2. Take a moment, press pause, and in a second you will see the solution after you've attempted it. Okay, press pause now. Okay, hopefully you pressed pause and you didn't forget, because I'm going to reveal the answer to number 2. Check your work. Here we've extracted, you'll notice, the x squared plus 1 doesn't factor farther, so don't fall into that trap. So everything on the outside here was completed. I didn't write it over and over and over, I just brought it down to the final answer. But you will notice that inside the brackets, after I combined like terms and I started the factoring process all over again, that I extracted a 4 out of those 3 things. Now instead of having the 4 floating right here in the final answer, I combined the 4 with the 4 that was already extracted to make this 16. So 4 was basically extracted twice to make that 16. I usually frown upon leaving the 4s in those 2 locations, so please combine like terms when you have a coefficients throughout the factoring process. So hopefully that looks good to you. I'm going to throw up problem number 3. As soon as I throw that up there, I'm going to ask you to press pause, work the problem out, and there we go. Okay, at this point, press pause on your computer, do the problem to the best of your ability. I'll see you in a second. Okay, we're back. How'd you do? Let's see. Okay, here was the extracting part. The extracting part had a binomial that factored twice farther. So that was this process of factoring what I extracted. Here, distributing, combining like terms to get to here. This guy factored to the 3x minus 14 and the x plus 8. And don't forget to write everything that you pulled out in the front. And that concludes problem number 3. Hopefully you are a master at factoring now.